Dear students, in this video I am giving an introduction to orthographic projection. So in this video I will be discussing about what is projection, what is orthographic projection, then about reference planes, then about quadrants, then the types of views, and also about first angle and third angle projections and its differences, and also the symbols used in orthographic projection. So first let's see what is a projection. For that I'm considering an object. Let it be a cubical shaped object. Now it is placed in front of a screen. So I'm drawing a screen behind that. It is an opaque screen. Okay, so this is the screen. Now I'm placing a light source. Let it be a torch or anything. So when I switch on the light source, there will be rays emerging out of this light source, passes the object and creates an image of the object on the screen. So this is called the image. You can see that the size of the object and image are little different. So this is basically what is called projection. So here the light rays or projectors goes past the object and creates an image or a shadow of this object on the screen. But this kind of projection will not give the true shape of object in the projection. So that is where the orthographic projection comes into picture. So let us now see what an orthographic projection is. Here also I have drawn an object and a screen and light rays from some distant light source. Okay. Here also the light rays past the object is creating an image or shadow on the screen. But you can see that the image is of the true shape and size of that of the object. That is because the light rays or the projectors are parallel. All the light rays or projectors are parallel here. In the previous case, they were not. And also, the light rays or projectors are making a 90-degree or right angles with the plane of projection. So these are the two conditions for orthographic projection. That is, the projectors should be parallel. That means the light source is at a very far away distance. And also the second condition is that projectors should make 90-degree with the plane of projection. Our next topic of interest is quadrants. In mathematics, generally, you draw quadrants like this, drawing x-axis and y-axis and dividing the plane into 4 quadrants. That is, first quadrant, second quadrant, third quadrant, and fourth quadrant like this. But in engineering drawing or in orthographic projection, instead of dividing the plane into 4 equal parts, we are dividing the space into 4 equal parts using 2 planes. One is horizontal plane and another one is vertical plane. So these two are the reference planes. So here we have divided the space into 4 quadrants and marked first, second, third and fourth quadrants. So let us see this quadrants in engineering drawing in a little more detail. So I have drawn the same reference planes, that is horizontal plane and vertical plane, which divides the space into 4 quadrants. You can see here the space above HP and in front of VP is called the first quadrant. Similarly, the second quadrant is the region or space above HP and behind VP. Okay, now let's see what is the third quadrant. Third quadrant is the space below HP and behind VP. Next, or finally, we have the fourth quadrant where it is the region below HP and in front of VP. So, if you draw the projections by keeping the object in the first quadrant, this convention is called first angle projection, and if the object is placed in the third quadrant and projections are drawn, the convention is called third angle projection. Let me now explain the different types of views. So we are considering the first angle projection here. So we are only taking the first quadrant, that is the region above HP and in front of VP. The HP and VP intersects at a line called XY line, that is our basic reference line. Now let us say the object is placed here. So looking from this side, you will be getting the front view. So I'm drawing the projectors like this. So the projectors passes the object and creates an image on the VP, and that is the front view. Looking from the top, let us draw the projectors. So looking from the top, the rays pass the object and creates an image on the horizontal plane, and that is called the top view. Now let us draw this onto a two-dimensional plane. So drawing XY and the above region is VP. So I'm drawing the front view here, and if I rotate the horizontal plane 90 degrees, the below portion, that is the portion below the XY line, is the HP, and on it we draw the top view. FV is the front view. It is also called elevation, and TV is the top view. It is also known as plan. Now let's see the difference between first angle projection and third angle projection. So the main difference is, in first angle projection, the object is placed above HP and in front of VP, whereas in third angle projection, the object is placed in the third quadrant, that is below HP and behind VP. Next, in first angle projection, the front view is above XY line and top view is below XY line. And in third angle projection, it will be right opposite of that. That is, front view is below XY line and top view is above XY line. Let us see the next point or difference. This first angle projection is used in India, Russia and some European countries, whereas the third angle projection is used in USA. Now let me also draw the symbols used in first angle and third angle projection. So in first angle projection, this will be the symbol used, and in third angle projection, this what I'm drawing here is the symbol used. So if you see this symbol, you can confirm that it is a third angle projection.